Hi guys, welcome back to a new IMONST video. So in this video, we'll be talking about senior only problems, which are from problem 16 to 18. Now, I only talked in 3 problems because these are significantly harder than your previous ones. So let's just start. Now, given integers a, b, c, d with a larger than b larger than c larger than d, and then d larger than 1. So we have ac squared minus bd squared plus ad squared minus bc squared equals 2020. So find a plus b plus c plus d. Now, looking at this, we can kind of rearrange this into something like this. So we would have a squared, c squared plus d squared, minus b squared, c squared plus d squared. No, actually it's the opposite, but it's the same anyways. Then we will have a squared minus b squared, and then c squared plus d squared. Right. Now, since we have d larger than 1, so d minimum is 2, then c minimum is 3, b minimum is 4, and then a minimum is 5. Right. So the minimum for c squared plus d squared, it would be 2 squared plus 3 squared, it will be 13. Then the minimum for a squared minus b squared, it will be 5 squared minus 4 squared, it will be 9. Okay, so if you want to if you want to break up 2020 into 2 divisors, so 2020 equals to something times something, well, we have 1 times 2020, 2 times 1010, 4 times 505, 5 times 404, 10 times 202, and then we also have 20 times 101. Okay, so as we see this, we want both of these numbers to be larger than 9. Okay, larger than or equal to 9. So as we can see here, for the 6 pairs we've created, we have 1, 2, 4, and 5, which are all smaller than 9. So these are not possible. So we're left with 10 times 202 and 20 times 101. So let's see first. Before that, I want to introduce the mod concept. Mod for squares. Okay, so if you guys do not know mod, you guys can check it out on the web. It's just modular arithmetic. I don't know. I think this is like a recurring topic in most of my Math Olympiad solution videos. Anyways, so we'll be using mod 4 this time. So divisibility by 4 to tackle squares. Okay, so for any squares, a square, it will be congruent to either 0 or 1 mod 4. Okay, this is a fact. So why is this so? Because we have 2k squared, which will be 4k squared. 2k whole thing squared is 4k squared, which is obviously a multiple of 4. Then we have some odd numbers, odd square number. Then we will have 2k plus 1 squared, because this is an even number. Even number plus 1 is always odd. So we will have 4k squared plus 4k plus 1. Both of these are obviously multiples of 4. And then we have 1. So the remainder is 1 when divided by 4. Now, looking at this, a squared minus b squared, we would have, okay, what are the possibilities for the remainder when divided by 4? So we could have either 0 minus 0 or 1 minus 1, which is 0. Then we could have 1 minus 0, which is 1. Then we could have 0 minus 1, which is minus 1. Then in mod 4, you can just plus 4, so it will become 3. Then, do you have a 2 here? No, right? So just these possibilities. So these are for any a squared minus b squared, okay? So for c squared plus d squared, what are the possibilities of the result when divided by 4, the remainder, okay? We will have 0 plus 0 equals to 2. We have 1 plus 0 plus 1 equals to 1. 1 plus 1 equals to 2. And then that's it. No more, okay? So as we can see, a squared minus b squared, the result must be, the results remainder when divided by 4 must be either 0, 1, or 3. And then c squared plus d squared, the result when divided by 4 must have a remainder of 0, 1, or 2. So now let's check 10 and 202. Okay, so 10 when divided by 4 will leave us a remainder of what? Okay, okay, so 10 equals to 2 times 4 plus 2. So its remainder is 2. 202 is 50 times 4 plus 2. So its remainder is also 2. But again, note that a squared minus b squared does not leave any remainder of 2 when, so 10 times 2 2 is not possible also. So the only final possibility is 20 times 101, okay? So of course, 20 is a multiple of 4, so 0 appears in both, and then 101 when divided by 4 has a remainder of 1, which also appears in both. So we need to, again, in this case, we need to set 2 cases, okay? So 20 times 101, right? So we have case 1. Case 1 would be a squared minus b squared equals 101. No, and then c squared, wait. A squared plus a squared minus b squared equals to 20, and then c squared plus d squared equals to 101. Now, since for 101, we would have only 10 squared plus 1 squared. You can check this for yourself. No other is possible. But then look again. This must be c and this must be d. But as stated in our question, d is strictly larger than 1, so d cannot be 1. So this case is not possible. So we cancel this case, so we go to the second case. It will be a squared minus b squared equals to 101. And then we would have c squared plus d squared equals to 20. So for this one, we would only have 4 squared plus 2 squared. So c is obviously 4, then d is obviously 2. So a squared minus b squared is equal to 101. A plus b times a minus b would be 101 times 1. So you do a bit of addition yourself. We'll find that a equals to 51, b equals to 50. And this is the only set. So a equals 51, b equals 50, c equals to 4, and d equals to 2. This is the only legitimate set for this. So what it wants is find a plus b plus c plus d. So just add up 51 plus 50 plus 4 plus 2. We will get a final answer of 107. So this is the answer to senior question 16. Of course, using mod 4 is a very powerful tool, so I'm just introducing it here. Of course, if you still didn't know what mod is, you could check out my previous videos. I think I've mentioned it somewhere else, maybe my future videos, I don't know. Okay, so now let's look at problem 17. It is known that the number of female students in the class is more than 48% but less than 50% of the total number of students. What is the smallest possible number of students in the class? Now, between 48 and 50% doesn't necessarily mean it's 49%. It could be 48.67%. It could be 49.73%. It could be a decimal. That's it. So let us let the number of female students be A, and then the number of total students represented by T be B. So A over B is lesser than 48%. It's more than 48% but lesser than 50%, right? So we will have 48 over 100, A over B, and then 1 over 2, right? So we can just turn this into 12 and 25. Now, what we want to do is we want to remove all the denominators. So we will be doing this by multiplying by 50b. Why? As you can see, 25, 2 and b multiplied together up to be a 50b. So we would have 50a in the middle, and then for the left it would be 24, I think it's 24b, and then for the left side will be 25b. Now, if we minus all three by 25b, we will have our rightmost set as 0, and then we will have 50a minus 25b over here, and then we will have a negative b over here, right? So we want our negative b to be the maximum because b is the minimum. So negative b is larger than, we can take a 25 here. So 25 to a minus b, then 0, right? So this one, we want it to be the we want this to be the maximum because it's a negative number. So 25 to a minus b is smaller than 0. So we will have multiples like, negative 25, negative 50, negative 75, right? Since we want our b to be a minimum, so we would obviously take this. Now, since this is obviously an even number, then if we want to minus this, if we want to get a negative 25, which is 25 times negative 1, so 2a minus b is of course negative 1, 2a equals to b minus 1, right? So b is odd, and then negative b is smaller than negative 25, which means b is larger than 25. So the smallest odd number larger than 25 would obviously be 27. So for problem 17, the answer would be 27. Okay, so this is it. I hope you guys understood it. If you don't, write it down in the comments something. Okay, now for the final question of the day, problem 18. What is the maximum possible number of reflex angle inside a polygon with 100 sides? Now, for you guys who forgot what the definition of a reflex angle is, it's an angle, so I'll just represent it by using theta, which is larger than 180 degrees but smaller than 360 degrees. So it would look something like this. This is a reflex angle, okay? Now, it could be 180.1 degrees. It's the reflex angle. It could be 359.9 degrees. It's also a reflex angle, okay? So, for a polygon with 100 sides, now, upon seeing this, we will be first thinking about the angle sum, right? Sum of angle, sum of interior angle. Okay, using the formula n minus 2 times 180 degrees, right? So n minus 2 times 180 degrees would give us 100 minus 2 times 180 degrees is 98 times 180 degrees. So, it's impossible to have 100 reflex angle inside a polygon with 100 sides because the maximum is 98 times 180 degrees, right? So if you have 98 reflex angles, it would exceed 98 times 180 degrees. So this is not possible. But if you have 97 reflex angles, okay, you could do something like 97 times 180 plus 1, then plus this thing minus this thing, plus some things to add up to become 98 times 180 degrees. It's possible, right? Smaller, 180.1 degrees, sorry, I messed up. So 97 times 180.1 degrees plus a bit of stuff would equal 98 times 180 degrees. So this would be the theoretical maximum. So we would want to demonstrate that this in fact is possible, okay? So let's start small. So for a polygon with 4 sides, meaning a quadrilateral, we will have 1 reflex angle. For a polygon with 5 sides, 2 reflex angles over here. And then for a polygon with 6 sides, 3 reflex angles, and so on and so forth. We can do with, so this one would have 100 sides, I think. So I don't know, this is very minuscule. So this one would look out to be like a near perfect circle, but it's not. So we have 2 sides here, and then here we have 98 sides, which will give us 97 reflex angles, okay? So for problem 18, 97 is the theoretical maximum and it's the real maximum, okay? So problem 18 solved. So this is the video for today. It's quite short, but if you guys have anything that you found anything that I explained wrongly, or there's something that you don't understand, write it down in the comments. We'll see you guys in the next video. Bye-bye.